Good morning, everyone. Today we are going to do ECE249 Pyqs of Unit 3 Introduction to Number Systems and Logic Gates. So, our question 1 is in a two variable K map, what is the minimum number of adjacent cells that can be combined to simplify a Boolean expression? Two variable K map. Options are option A is 2, option B is 4, option C is 8, and option D is 16. Here they set two variable K map, and for calculating the adjacent cells, the formula is 2 raised to power n, means n is the number of variables, 2 raised to power 2, which is 4 cells. So the correct answer is option B. The two variable K map has 4 cells, 2 into 2. Grouping all 4 cells, a power of 2 removes but both variables and yields a constant 1. So to eliminate both variables in one simplification step, you must combine all 4 adjacent cells. Moving on to question 3. Gray code of binary number 1011. Options are option A 1110, option B 1101, option C 1001, option D 1111. So the correct answer is A. To convert binary to gray code, write down the first number as it is. From the other numbers, apply XOR gate for the next bits. The correct answer is 1110. Moving on to the third question. In BCD, each decimal is represented by option A 2 bits, option B 3 bits, option C 4 bits, option D 5 bits. So the correct answer is option C, 4 bits. In a BCD, each decimal digit 0 to 9 is encoded using binary bits. So every digit is stored separately instead of converting the whole number to pure binary number. Moving on to the fourth question, gray code is used for option A, speed up computation, option B, avoid errors in digital circuits, option C, save memory, option D, represents fractions. So the correct answer is option B. Gray code changes only one bit at a time between successive numbers, reducing the chance of errors during transitions in digital circuits. Question 5. 1x complement for 1010 is option A 0101, option B 1011, option C 1101, option D 1110. So the correct answer is option A. Flip all bits of 1010 gives 0101. Moving on to the sixth question, convert the octal number 56 to the binary number. Option A 10110, option B 111000, option C 101010, option D 110101. I hope you all have paused the video and calculated the answer. So the correct answer is option A. To convert 56 octal to binary, we convert each digit into 3 bits, binary bits, because each octal number digit represents the value from 0 to 7, which fits in the 3 bits. So 5, 8 becomes 101 and 6, 8 becomes 6, 8 means 6 in octal number becomes 110. Combining these gives us 10110. Moving on to the question 7th, the sum of products SOP expressions represents a logic function using option A AND gate followed by OR gate, option B OR gate followed by AND gate, option C XOR gate, option D NOT gate. I hope you have paused the video and guessed the answer right. So the correct answer is option A. SOP forms are expressions that expresses a logic function as a sum which is or of the multiple products and terms. Each product term represents a combination of variables that makes the function true. Moving on to the 8th MCQ, number of cells in a 3 variable K map is option A 4, option B 8, option C 16, option D 32. I hope you all know the formula and have calculated the answer. So move on to the answer. So the correct answer is option B, which is 8. Number of cells is equal to 2 raised to power 3 is equal to 2 into 2 into 2 is equal to 8 cells. Moving on to the ninth question. How many bits are needed to represent 12 distinct value in 3-bit binary code? Options are option A 1 bit, option B 2 bits, option C 4 bits, option D 3 bits. Moving on to the answer. So the correct answer is option C, which is 4 bits. A 3-bit code can represent only 2 raised to power 3, which means 8 values. To represent 12 distinct values, we need the next higher highest power of 2, since it's 2 raised to power 4, which means is equal to 16, is greater than equal to 12. So 4 bits are required. Moving on to the 10th question. Simplify the function f(a)(b), where m is equal to minterms is equal to 1, comma 2 using a two variable k map. Options are option A, B, option B, A plus B, option C, A complement, option D, A. I hope you all have paused the video and calculated the right answer. So the right answer for this is A, which means B. In the K map, min terms are 1 and 3, corresponding to cells where B is equal to A, whereas A is changing 0 and 1, but B remains same, which is equal to 1. Grouping them gives the simplified expression, which is equal to F is equal to B. So our 11th MCQ is simplify the expression A bracket A plus B. So the options are option A, AB, option B, 1, option C, 1 plus AB, option D, A. I hope you all have paused the video and guessed the answer. So the right answer is option D, which is A. How to do it? Distribute and over or A bracket A plus B. If you will open it, it will be equivalent to A into A plus A into B. Then apply idempotent law on A into A, which is equal to A. Hence, we will get A is equal to A into B. Now apply absorption law, which is A plus AB, which is equal to A. Sorry, by mistake, I have written here A. It will be like this: A plus A into B. Moving on to the 12th question. The output will be low for any case when one or more inputs are 0 in A and AND. Options are option A, OR gate, option B, NOT gate, option C, AND gate, option D, NAND gate. I hope you all have guessed the answer. Moving on to the answer. So the answer is AND gate. In an AND gate, the output is high only if all inputs are high. So if one or more inputs are 0 means low, the output immediately goes low means 0. Moving on to the 13th question. Which of the following is universal gate? Options. Option A, NOR. Option B, XOR. Option C, XOR. Option D, OR. So the correct answer is option A. A universal gate is one with which you can implement all basic logic gates, which are AND or NOT. Both NAND and NOR have this property. Since the option given here is NOT, that's the right pick. Moving on to the next question. Question number 14. The code where all successive numbers differ from their preceding number by a single bit. Options. Option A, arithmetic code. Option B, BCD. Option C, ECE3 code. Option D, gray code. I hope you all have guessed the answer. So the correct answer is option D, gray code. In gray code, each successive number differs from the previous one by only one bit change. This minimizes error during transition. Moving on to the next question. The gray code equivalent of 28 decimal will be. Options are option A, 10010, option B, 10111, option C, 1011, option D, 10110. I hope you all have paused the video and calculated this. Now let's see the answer. So the correct answer for this question is option A. Convert 28 to binary. Converting 28 decimal into binary would be 11100. Now binary to gray code conversion. First gray bit is equivalent to first binary bit. Each next gray bit is equal to XOR of previous binary bit and current binary bit. Gray code equivalent of 28 is 10010. Moving on to the next question. ECE3 code of 15 hexadecimal is. Options are option A, 001000001, option B, 01010100, option C, 000101001, option D, 01000100. I hope you all have paused the video and calculated your answer. Hence the required answer for this question is option B. Now let's see how to do this. Convert hexadecimal to decimal. 15 is given hexadecimal. We have to convert into decimal. This is decimal. Here it is bracket. 21 is the decimal of 15. How to convert? 16 raised power 0 multiplied by 5 plus 16 raised power 1 multiplied by 1 is equal to 21. When we convert 15 hexadecimal into decimal, it will be 21 of decimal. Break the decimal into the digits. 21 digits of 21 are 2 and 1. Now apply ECE3 rule for each decimal digit. Add 3 and then write in 4-bit BCD form. Digit 2 plus 3 is equal to 5. Then 4-bit BCD form would be 0101. Digit 1 plus 3 is equal to 4. Hence BCD 4-bit BCD form is 0100. Combined, so our required ECE3 code is 01010100, which is option B here. Moving on to the 17th question. The two input logic gates that give high output when both or any one of its input is A and. Options are option A, AND gate, option B, OR gate, option C is OR gate, option D all of this. So the required answer for this question is B option, which is OR gate. And OR gate outputs high if any one input or both inputs are high. It goes only low when all inputs are low. Moving on to the next question. For realizing Boolean expression AC plus AD plus BC plus BD, the number of inputs are option A 4, option B 5, option C 16, option D 2. I hope you all have paused the video and guessed the answer. Moving on to the correct answer. Correct answer for question 18 is A. Means 4 inputs. Identify variables which are A, B, C, D are present. That means there are 4 distinct inputs. Now check the terms. Terms are AC, AD, BC, BD. Each is the product of 2 inputs but still only from that set A, B, C, D. So conclusion is the circuit will need 4 inputs A, B, C and D. Moving on to the next question. Question number 19. Gate formed by inverting the output of AND gate is. Options are A. NAND, B. OR, C. NOR, D. NOT gate. As the correct answer to question 19 is A. NAND gate. A NAND gate is basically an AND gate followed by a NOT gate. AND gate gives high if only if all inputs are high. Inverting the output flips it. High becomes low and low becomes high. So output NOT bracket AND gate is equivalent to NAND gate. Moving on to question number 20. Simplify A plus B complement plus A complement B is same as options are option A C complement, option B 0, option C 1, option D C. I hope you all have calculated the answer rightly. Now moving to the correct answer of question number 20 is C. Group terms cleverly. You have to group A plus A complement B plus B complement. Then apply absorption rule on A plus A complement B, which would be equivalent to A plus B. Now the expression becomes A plus B and the leftover which is plus B complement. Now B plus B complement as we all know is 1 as per complementary rule. Now we are left with only A plus 1. You can see here we are left with A plus 1. A plus 1 is also equal to 1. I hope you all get all the MCQs right. 20 out of 20 MCQs. These are Pyqs. So I hope you get all the answers right. Thank you so very much.